So yeah, I did get asked to do this at the last minute, but this is the same presentation I was going to give anyway. So if you're interested in a keynote of the really big problems of today in the security industry, I'm afraid you're going to have to be disappointed. So let's go through talking about Kerberos. Clearly everyone's favorite authentication protocol. I'm going to do, obviously, the usual very quick, what the hell is Kerberos and why should you care? And I'm also going to talk about tooling for the purposes of manipulating Kerberos and playing with Kerberos. And of course, Kerberos is quite important for things like red teaming exercises or infrastructure testing, because, of course, Windows enterprise networks use Kerberos all the time to do authentication. So it's kind of interesting to have tooling to analyze the security aspects of it. But I'm also going to talk about my tooling, and if you actually look at the types of things I have been doing recently, like the bugs that I've been reporting in Google Project Zero, you'll notice that there has been a bit of a theme of late of Windows authentication and Kerberos specifically, vulnerabilities, finding interesting bugs in Kerberos and interesting behaviors in Kerberos, which I have found by writing my own tooling. And I want to kind of show some of that tooling today so that you perhaps can also look for your own bugs in the Kerberos stack and actually try and find interesting stuff there. And as we go through, there'll be plenty of demos, all in PowerShell pretty much, because that's just the types of things I write. So the link is there. All the tooling is always on GitHub. Now, it isn't just like Kerberos only stuff. There's loads and loads of tooling in there for doing Windows security analysis, which is why it's called attack surface analysis tools, but it actually does a whole lot more than just that. So why should I care about Kerberos? Well, because it is used in an awful lot of enterprise networks across the world. Now, Microsoft would prefer that you start using some more modern protocols. If you're using Azure Active Directory, you might be using the sort of like OAuth-based authentication protocols, but also they've implemented like HTTP-based authentication protocols, which actually are kind of just Kerberos, but they've just changed the structure. So some of the principles of Kerberos are still actually kind of applicable today. Now, there's plenty of Kerberos tooling out there. If you have done a lot of this sort of stuff, the sort of red teaming exercises, you've probably seen either Kekeo, I'm not even sure I'm pronouncing that correctly, or Rubeus. These are explicitly offensive tooling. Like their purpose is kind of so that you found yourself on a machine somewhere and you want to manipulate Kerberos to do something interesting. But my tooling isn't about offensive tooling. I would say mine is more like a library. And so you have things like Kerberos.net, which is written in .NET. You've got Kerberos in Go, you've got Kerberos in Python, all these different ones. So what's so special about mine? If there's already existing libraries, why did I do it? Well, one of the reasons was I wrote it because I wanted to understand how Kerberos works. And that is really a very salient point for doing any security research, is that yes, you can rely on somebody else's code and somebody else's tooling, but you don't necessarily then fully understand how things work. So for me, at least, it was kind of useful for me to rewrite a lot of the primitives of Kerberos so that I could actually understand how it really worked. Of course, you're not going to necessarily rewrite your own tooling. But the other reason is I've written this with the explicit purpose of finding vulnerabilities. And if that is your goal, then great. If your goal is to do red teaming exercises, then something like Rubeus is probably a better bet in many cases. So, background. That's Kerberos. Simple, you see? Nice, happy locks, right? Everyone is happy. It is actually quite simple in principle, but is quite complicated when you actually look at it in actual detail. But at a basic level, every user in a Kerberos realm, as they call it, which is synonymous with like a Windows domain, usually has some sort of long-term key material. And this key is basically used to sort of prove that you are who you say you are. And the simplest way of achieving that is by converting, say, your user's password into some sort of key material that you can access. So the client, Bob, wants to log into his workstation. He can send a request to the KDC, the Key Distribution Center, which is the sort of Kerberos domain controller, basically, and say, hey, I've got my key. Can you authenticate me? And he goes, sure, and generates a ticket, or specifically a ticket granting ticket. And this is a special kind of artifact in Kerberos, which allows you to then authenticate to different services. When you want to do that service authentication, say you want to contact an SMB server, you would actually have to then take that ticket granting ticket and the associated key that you've been given, and use that to generate another request to the KDC to say, hey, can you also give me a ticket which corresponds to this service? And that's using something called a service principal name, and this is this CIFS/ABC. And you can use that then to prove that you are who you say you are to the service. So one of the things that I've written in my tooling is actually to control this directly. So these are all like simple PowerShell commands. So the first one is like create that initial authentication request. And this is literally like, this hides a massive amount of complexity. Like Kerberos uses ASN1, everyone's favorite serialization protocol or data structure protocol. And so it has to build this ASN1 structure, which you can then send to the KDC. The actual protocol itself is you've got to convert, say, the password into that key material, which, because you don't send the password directly, it's always like a derived key. And so that one command generates that request, but it doesn't actually do anything just yet. You still got to send it to the KDC. So you can use DNS to resolve the KDC address. And then you can actually send that request to the domain controller, or the KDC, and get back your TGT. Now, if you're used to things like Rubeus or Kekeo or Mimikatz, you probably use the Kirby file format, and this is like a credential structure. So you can actually import and export these tickets as well once you've got it, so that you can save them, you can copy them to, say, a Linux machine, run different tooling, depending on what you've got. And so you could use this on a different command. And I've also, even though this is Windows specific, my libraries are Windows specific, all this will actually work on Linux if you just use .NET Core. So if you use PowerShell Core, you can actually run these commands on a Linux machine and do all the Kerberos authentication, because none of this relies on Windows. You can also use some ticket caching. So again, there's another structure called the credential cache, which you can manipulate. And this just allows you to maintain like a list of tickets that you've already requested. And it makes things easier to actually handle the structures. And then just finally, there's also some key handling. Obviously, the keys you need to derive from the passwords, or, well, most of the time you have to derive from the passwords. But you can also get them in hex format, so we'll see cases where we need to convert keys into something that my tooling can use from a hex-based string, basically. And from that, you can actually just export and import key tabs. And again, this is like a standard format, usually used by the MIT libraries. So again, if you have something on Linux and you can generate the keys on a Windows machine, you can port this across to a Linux box and then re-import them there. So, I have to log in my VMs. As I say, you can just, this is just a simple Windows machine. It doesn't have to be the main join because, of course, the libraries, you don't have to necessarily join the domains on that. But this does allow you to run this on your domain. So you can just do this new Kerberos AS request. In this particular case, we can either specify a key. There's also something called pkinit, which allows you to use a certificate to do authentication. It does that as well. We'll just use the password for now because, of course, password's easiest. Give it the client. We'll give him Alice, and then his realm, which is currently domain.local. And as I say, that doesn't actually then go anywhere just yet. But instead, what we got to do is we can send the TGT to the Kerberos KDC. Help if I do send, and just request, and hopefully it should just work. So the interesting thing about all this is, of course, you've now got your Kerberos tickets, and because this is all just a object model, you can actually like print off information about that ticket. So you could inspect it manually if you wanted to. There's various formatting commands. And so this is the structure of the ticket. But unfortunately, it's all encrypted. And in this particular case, it's encrypted using a key which we don't directly have access to. So, well, you shouldn't have access to it. This is the key which is owned by the KDC. And of course, if you had this key, you can basically pretend to be anybody you like on the domain, which would be probably bad, would generally be considered a bad thing. But in this case, we don't happen to have it. However, we could potentially get it. I have a getKeys function. If I just change this to KERB-TGT. So this is using a module called dsinternals, which I didn't write. But this allows you to basically use replication to query any key in the domain. So we can just get the Kerberos TGT key, and then we can decrypt that ticket and see what it actually contains. So let's hope this actually works. In this particular case, we can just convert them using this get Kerberos key, and we can actually then convert that into real keys. So get keys. I type in my super secret administrator password, which of course most people shouldn't know. This is domain administrator. Okay. And we should now have a few keys for the KERB-TGT user. Okay, so hopefully we can now decrypt this. So we go decrypt and then go keys 0. Oops. We should hopefully. Apparently, I can't type today. One of those mornings. Okay, so now we've actually got a substantial amount more data in here. So this is now the ticket which has been fully decrypted, and again, it prints out all the useful information you might be interested in. Things like the privileged attribute certificate. This is how Kerberos identifies who you are to everybody else. And it contains like your user SID, your user information, your user groups, and we'll see an example of how this can be abused later on to do some interesting stuff. Now, as I say, normally you can't decrypt this, but in certain cases you can. Okay. So that was using like actual like manual manually authenticating to the domain. But of course, you may find yourself like, you may just want to access Kerberos for the current user who's already logged on. You don't want to actually call out to the KDC. And Windows actually provides a set of APIs to interact with Kerberos in a sort of simplistic form. In a sort of abstract form. It's designed for all different types of authentication, like NTLM, Kerberos. But the main sort of APIs we need, at least on the client, is this initialized security context. And this will allow your process to get access to your Kerberos authentication without ever knowing your own keys or your own password necessarily. So, of course, if you find yourself on a machine, you can use this to get Kerberos authentication running. So again, I've got APIs to handle this. So these wrap all those existing Win32 APIs in PowerShell commands and provide them in my opinion, a fairly easy, relatively speaking, to use API set or command set. So we have you need to get a credential handle which says, I want to use Kerberos, please. You then need to call that initialized security context, and that will return back a Kerberos AP request, which could be used to send to the service. For that, you need the service principal name. So in this case, we just pick an arbitrary one. And again, as I say, in this case, if you do format LSA auth token, you can actually format the AP request in its entirety, or decrypt it, as I say, in this particular case. On the server side, you can also do the server side. And the interesting thing about the server side, from a security research perspective, is that once you've done the authentication, you can then get out the access token associated with that authentication. And potentially you could impersonate it or do nasty things to it and gain additional privilege escalation on the local system. So those are the sort of things that I've been looking for of late. The user itself also has their own system ticket cache associated with them. So any ticket that you see being accessed gets stored inside the ticket cache, so it doesn't have to keep going out to the KDC every single time and say, hey, give me that ticket again because I forgot the previous one. So you can actually query that and get access to key material for these tickets and actually make requests yourself without ever getting Windows involved, which is a powerful primitive which we'll see a use for in a second. Now, you can query your own TGT, which is basically the root of all your authentication, but Windows generously zeroes it out for you. Unless you're running as the system privileged user, it will zero out your session key, which is kind of annoying. But it does turn out there's an interesting trick you can perform, and this was pointed out by the author of Mimikatz. You can just do this and steal a TGT without Windows getting wise. And it's basically abusing delegation. Now, I don't know how many people know about unconstrained delegation in Kerberos. It's generally considered a bad idea, and it's one of these things that Microsoft have been trying to remove from Kerberos for a while. But in this particular case, it works to our advantage because we can basically, what actually happens under the hood is when you make a request, say, to a service which has delegation enabled, so the KDC in this case always has delegation enabled, it will actually package up your own TGT into that ticket. But because of the Kerberos ticket cache, we can extract the session key for the ticket you're sending out and decrypt that TGT and then just extract it ourselves and then use that to do funky stuff. And again, we'll see an example of that in a bit. So we can actually just extract that out fairly easily. If I can find the particular thing, where is it? There we are. So this is a simple piece of code, relatively speaking. And we use the Windows APIs to get this delegation ticket. And then once we get it, we can just get the TGT back. And it's now we have full access to that user's authentication credentials for Kerberos. So I just run that. And we should have, oops. Again, my typing is absolutely terrible this morning. And again, it's just a TGT. And from there, you can actually use that in the same way you could use it before. So of course you can format it and all that sort of stuff. But it is that, and we should have, just to prove a point, we have a session key with key. And obviously that's not 0. So we can actually use that TGT now without actually having to get Windows involved at all, which is, again, quite useful for certain things, as we'll see. Okay. So one of the things is if you have control over the authentication process, you can actually bypass UAC, as long as you're, of course, running as an administrator already, right? Like Microsoft do not consider UAC to be a security boundary. So any bugs in UAC are like, meh, whatever, we're not going to fix them. Why should we bother, right? But of course, it's such an important non-security boundary that they go to great lengths to make sure that you don't cross it until you cross it, of course, which is one of the sort of weird parts of UAC. Like, they've gone to so much effort, but why bother if it was not a security boundary in the first place? But there we go. So there's a structure which can end up inside a Kerberos ticket, which says basically the user which created this Kerberos ticket was actually a low privilege user but running UAC. So when you receive that ticket, don't give them admin privileges, because that would be bad. That would be crossing a non-security boundary, and that would be the end of the world. And depending on what values are in that structure will depend on whether it actually filters your token, which is the action of taking your administrator token and removing administrator access rights so that your UAC user, say you're connecting over SMB to the local system, it will only connect as like a normal user. It won't connect as an administrator user, even if you're running as a UAC admin. So if we can affect this filtering process, we can bypass UAC in that regard. So all we need to do, realistically, is can we remove this restriction entry? Can we remove this data from the Kerberos ticket? Well, in normal cases, no, because if you're using the Windows APIs, all that actually happens is it automatically inserts this data for you, and you have no choice at that point. Like, it's always going to do it. But it turns out, if you can control the entire Kerberos authentication process for that user, then you can just say, give me a service ticket, but don't add this extra data because I don't want it. Just let me authenticate without this. And that is all we need to do. And once we've got things like the TGT, we can do our own authentication, and we can therefore get a ticket which doesn't have this UAC restriction in it. Now, in this particular case, it's actually even simpler. We don't actually need the TGT necessarily for the UAC admin bypass, because if we request the service ticket, we can get the session key for it. Now, there's a special kind of operation called a renewal in Kerberos, because each service ticket has like an expiry date on it. But you can renew it and say, hey, I want to get another couple of days on this ticket, please. Can you do that for me? And you send it to the KDC, and the KDC has various policies as to whether it's allowed to do that or not. But if it will do it, it will return you a new ticket with a new date on it. But crucially, it will also allow you to specify any of those extra data attributes that you like. And of course, you can specify nothing, please. It will not convert, it will not copy across these structures into the new ticket from the old ticket. So in this particular case, we can just renew that ticket, tell it to not specify any authorization data, And then we can just log on to, say, the service control manager on the local system and say, hey, can I just not be a restricted admin? Sure. I can now create services or whatever I need to do. So to do that, you can use another command, this Kerberos TGS request. It's kind of like the AS request one, but for the service ticket. And just give it an existing ticket with a session key and say, I want to renew that, please. If you then send it to the KDC, that will actually return you the service ticket. And then you can actually, my tooling has basically a built-in library to construct Windows RPC clients on the fly. It can be used to extract RPC information from binaries and then just generate like a C# client on the fly. And you can use arbitrary Kerberos authentication in that. And we can use that to basically talk to the SCM as our full admin. Okay. So we can demo that one. Down in UAC bypass. We are currently a non-admin. Hopefully. Yeah, so if we try to say write hello to the Windows folder, say, it's going to fail on us because we're not admin. Okay, we're definitely not admin. But if we do UAC bypass, in here what we do, we get that ticket for the service. We then do the renewal, we just send it out to the renewal purposes, and then we use this to construct our RPC client on the fly and talk over Kerberos to it. And then what we'll do is we'll just create a service which has full access to everybody. So once it's created, we can just manipulate it from a normal user. We could change it to, say, run something of our choosing and get system privileges using that. So let's just run that. Okay, oops, service name. Hello 44con, I suppose, probably always a good one. Command, we want to run Notepad, which is, ever since they made calculator like that special weird modern UI, you can't run calculator at system anymore, or it's very difficult to do so. So Notepad, unfortunately, is our next best bet. So it all just sort of magically works, but we should hopefully see we have now the hello 44con service. If we can just print data about that. Apparently it will run Notepad, and we should even be able to start it. Hello 44com. And of course, it's not going to seemingly do an awful lot, because of course, Notepad isn't a service. But we do now have Notepad running as a system. So again, it's relatively easy to bypass UAC if you have full control over the Kerberos authentication process. I'll let that to time out. So another interesting area of Kerberos research is similar to the sort of UAC stuff. If you have full control over the Kerberos authentication process, you can use it to get admin privileges in the limited service accounts. So limited service accounts, they're not administrators, but they generally do have impersonate privilege. And when you have impersonate privilege on Windows, you can pretend to be anyone you like. But the key is you need to have an access token for that anyone in order to actually exploit that in a useful way. And so we can actually abuse Kerberos in this regard to get us an access token which we can impersonate and get admin privileges on the local machine. So the simplest one is using something called service for user to self. It's a bit of a mouthful. This is a function of Kerberos which allows you to basically get a service ticket for any user, but only for yourself. So it effectively allows you to impersonate any user on the domain. Now, the weird thing is, there is actually a built-in API for this. You can basically log on as a service for user to self user, and you call LSA logon user, that makes a request out to the KDC for you, and it gives you an access token back. However, it gives you an access token back which is useless. If you're running a system, you can get back a useful access token, but the access token you get back as a limited service account is locked so that you can't impersonate it and do useful things with that. So that's kind of annoying, but it actually is, that's just a quirk of the APIs that Microsoft implemented. It's not actually how it really functions under the hood. All it's doing is it's saying, do you have this special TCB privilege? If not, get stuffed, basically, which is generous of it. So what we can do, again, now that we got that TGT, we can make, again, arbitrary requests to the KDC to do whatever we like. So if we're running as the network service user, so there's two service accounts, or two standard service accounts. There's network service, who has access to the machine's Kerberos account. So every computer has a Kerberos account, and network service has access to that Kerberos account and all the things that entail, so it's TGT, etc. However, there is a second one called local service, which doesn't have access to Kerberos, and we'll have to come back to that in a second. So if we get the TGT for that network service user, we can actually do all those things that the system was doing for us when we called LSA logon user, but never give it a chance to actually restrict our access to it. So we can just negotiate that, get an access token, and we've now got full access to that user. So again, we can go into here, S4U to self. We query for the user's TGT, get that back, and then we can just make this request for this S4U to self for any username. So for example, we can say, give me a ticket for the domain administrator. Now that won't give you access to the entire domain as domain administrator. That would be a terrible thing. But it will allow you to elevate privileges on the local machine. We then just get an access token, and in theory, once we got that back, we can then impersonate that user and get additional privileges. So in order to do that, oops, I wasn't expecting it to actually play audio there. Let me just start a process running as network service. So who am I? So we got network service. We can do, say, get Kerberos ticket to query its ticket cache, and we should see we got a couple of TGTs, etc., in there. So now if we do token equals S4U to self, and we give it, say, administrator for a domain administrator. Okay, we now should have a token, impersonation token, and if we actually try and write to say, if we go back to what we tried to do before and try and write to, say, the Windows folder, as network service, this should fail. And if it doesn't fail, I've done something horribly wrong. Oops, that's kind of annoying. Okay, definitely access denied. However, if I now wrap this in an impersonation, we get no errors, which is always a good sign. And this should now say hello. Okay. So if you find yourself as, say, network service or equivalent, you can use that Kerberos attack stuff to start gaining additional privileges. And it's stuff which you only sort of really find out when you can just play with these sort of artifacts and actually manipulate things. But I did mention that you've got a problem. If your local service, you don't have access to Kerberos. Like if I go back to here and start, oops, I managed to close that down. If I start a local service process and go get Kerberos ticket, we get nothing. And that's because local service has no access to your computer account. So how do we get around that? Well, the one interesting thing is, as long as you know your own user's key, you can effectively fake an entire ticket. And that's kind of just by design. Now, there are protections against it. So that privileged attribute certificate has signatures which aren't supposed to allow you to do this. However, Windows bypasses those protections and those checks if you're local service or network service or system. And so we can just lie about our who we are, and we can just create an arbitrary privilege attribute certificate, give ourselves admin privilege, all that sort of fun stuff. And there's loads of little bits and pieces we can access in that regard. If we could just craft our own pack. But there's a problem, even at network service, we don't know the network service's password and its key, because that's some randomly generated 200-character password which gets converted into a key. So how are we going to do this? Well, it turns out that we can just authenticate to any domain we like. And that domain controller, that KDC, can be anything we like. And it returns any SIDs we like. Now, that would be kind of annoying to set up normally, but it turns out that Windows provides a mechanism to basically say, if you try and authenticate to fake.local as a domain, well, its domain controller is actually on this address. And in fact, that domain controller can even be on the local host if you so desire. So there's tooling to basically do that. And then, of course, once you've got that, you need to create a fake KDC. Now, you could set up a server to do that. You could build an entire Windows domain. Well, no, I'll just write my own KDC in C#, and then you can just authenticate to the local machine. So the two commands there, or the bottom three commands, are all you need to do to set up a fake KDC, basically, running on the local machine. And then you can use the KDC pinning to do that. And again, the KDC server will also run on Linux if you're so inclined for that. So the idea here is that as our local service account, we can pin our fake KDC to the local host or to a fake server somewhere out there. When it makes then the connection, we can get it to create a ticket, which we can then decrypt. Because we control all the key material, so it doesn't matter what password we use, for example. We can say our password is password, because it doesn't matter. We're just authenticating as a completely unrelated user. And we can then use that, and because of the fact that they don't do the signature checking on the privileged attribute certificates, then we can get back an access token with virtually any groups we like. And again, even in local service account, we can then use that to get administrator privileges on the local machine. Okie dokie. So we are running as local service on this machine, or in this PowerShell, but we can see it. Where are we? Nope. It's in here somewhere. Create token. I really should have named these better for the particular demos that I was doing, so I can remember what it is. So in this case, we'll create a KDC. We'll set it to a SID of an actual real user, like the Alice user, because what that allows us to do is it ensures that we get their groups when we log on. Because we can't add the built-in administrators group, but we can add the domain administrators group. And the domain administrators group on a domain joined system usually grants the local administrator group as well. So we can use that to get full administrator access. We create a user, we just give it the username of lols, because why not, and the password of password. If we start the server running on the local host, and then we just pin that to that fake realm to our local machine, and then we just do authentication. And once we've done Windows authentication, we get back an access token, which we can again impersonate as local system or as local service and get ourselves administrator privileges. Okay, so am I on the right one? Yep, okay. So we are local service on this machine. Again, if we do create token, oops. Okay, nothing particularly interesting, no errors. No errors are always good. We can actually print that out, and like our user is fake lols, because why not? But we are a built-in administrator. So again, because our local service has impersonate privileges, we can now do the same thing we did before. Oops. And then we can say from local service, hi 44com, set content. And we should be able to just write that into 44com.txt. No errors, and we can just read that back out just to prove that I'm not lying to you. 44com. There we go. So we are pretty much at time. So I thought, obviously, it'd be nice to demonstrate some interesting vulnerability that I've found. Because all those things I've shown you up to now, they're just kind of by design. They're just not something Microsoft are going to fix, or certain ones you can fix by enabling the credential guard, which sort of protects Kerberos on your local machine by hiding a lot of Kerberos bits and pieces, like the keys, inside a virtual machine on the local system. But this is a vulnerability that I found about 3 months ago, and I thought it was kind of an interesting one. Unfortunately, we generally have a policy now or Project Zero has a policy where we can't discuss the full details of a vulnerability for up to 30 days after the patch was released. The idea being that people want to patch, but they don't want people telling them what's actually vulnerable and how the vulnerability works, and releasing proof of concept, because maybe they would get attacked in the meantime. Now you could say that people should patch quicker, all that sort of stuff, but that's never likely to happen. But anyway, so unfortunately I can't go into real minute detail about this issue, which is a shame, because it's a really fun issue. However, fortunately the advisory does actually give some hints as to what the problem is. So the hints are basically, it's a bug in the way in which Kerberos is handling the RC4 encryption scheme. And this is kind of known that RC4 is a bad thing. But the sort of best attacks on RC4 in Kerberos have been brute forcing the user's password based on RC4. But this particular case it's still kind of a brute forcing operation, but it can be done in enough time that I can finish before the end of this presentation. And as we'll see, it's pretty quick. The other thing is, in this particular case, there's two variants of this. This one, basically, you can, when you do the authentication, what's normally supposed to happen is you send a blob of data, which is encrypted using the user's key, to the KDC, and the KDC can then go, oh, that client knows that user's password, therefore I'm willing to send back the initial TGT to them, which is normally encrypted and contains the encrypted key associated with that. But there's a way of turning that off, and this is called pre-authentication data. So you can actually turn off this feature for individual users. Now, this particular variant, if you turn off pre-authentication data, and this is actually written in the advisory, it means that I can authenticate as that user just by a relatively simple brute forcing operation. So on here we have user Bob, because I'm not particularly good at naming things, so I have Alice and Bob, right? Come on, Windows, so terrible. And crucially, in these sort of account options, unfortunately it's quite small, and I can't make it very much easily bigger. So magnifier, oh, it is actually there. Okay. So you can see there is this do not require Kerberos pre-authentication, and as I say, this wouldn't normally allow you to trivially get like just run arbitrary code as that user. What it does is it just stops you having to prove that you know the key before the KDC will return you data. So crucially, because this is on this particular user, we can attack it. So let's go back to this. Okay, we just close some things down before we run. Okay, so go to our demos. See if I can remember what it's called. POC. Of course it is. Right. So this is actually written in C# just because it was easier thing to do. All those libraries that I've shown in PowerShell, you can also access all that API set from any .NET API. And as I say, you can of course use that in .NET Core on Mac OS or Linux. It's primarily designed for Windows usage, so there's loads of APIs which probably will blow up immediately if you try and use them, but we should be fine. So if I hit that, it's there, it's thinking about it, doing some stuff. Okay, fingers crossed this is actually going to work. Okay, so it has apparently got a TGT. And it's written it out to one of these Kirby files. So I can import that. Kerberos ticket, path, Bob TGT. Oops. No, I've broken something. Okay. I'm going to have to do it manually, which is never a good idea. Why is that? Okay, I've obviously done something horribly wrong. Oh, I know why. Microsoft have obviously done a pretty good job of making everything backwards compatible, except for when they don't make it backwards compatible, because so that was using PowerShell Core, and PowerShell Core has slightly different commands than normal PowerShell, because it's annoying. Because why not? Exactly. Import Kerberos ticket. Okay. So hopefully this should work. Okay. Woohoo. And we could now, with that, actually access anything we like as Bob. We could obviously create a new TGS request. TGS request, credential, TGT, and then give it a service name of our local machine. Oops. So obviously it's definitely one of those days. But yeah, so obviously in this particular case, it's because I'm a complete idiot, and it's actually called ticket, not TGT. Domain.local, yes, thank you. And then send Kerberos, KDC request, TGS. Okay. And we get back a ticket for that user, for Bob. So we can then use that to access anything as Bob. And we never had to know his password. We never had to actually ever see his password and just brute force our way to victory. Now, fortunately, it's fixed. So, of course, I would recommend you apply your patches at the most expedient time you can if you're running a Windows domain. So thanks for listening to that. I'm sorry it wasn't a boring, dry keynote, and instead was a boring, dry technical talk. But in a sort of unusual thing, I'm going to be in the workshop room after workshop 2, I think. Oh, yeah, okay. And yeah, you can, in theory, ask me anything, but of course caveats are going to apply to that, right? Because there are certain things I will definitely not be talking about in that sort of thing. But thanks for your time, and have a good rest of the conference.